Hello folks. In this video we're gonna continue working on this Aurora Immersion Day AWS workshop. So this time, instead of finishing off some other stuff, for example, I still haven't completed IAM authentication to access the database cluster, set up database activity streams, right? I'm just gonna do something different. I'm gonna actually finish the other things over here. So for example, ETL, my zero ETL integration with Amazon Redshift and all that. So let's try it out. So Amazon Aurora now supports zero ETL integration. So what is that? By the way, let's close these and we need to let me just copy this up and clear this up. Cool. So I think zero ETL is basically about how this is along with SageMaker, interesting, enables near real-time analytics and machine learning using data from Aurora. It's fully managed solution for making transactional data available in your analytics destination after it is returned to an Aurora DB cluster. This is the process of combining data from multiple sources into a large central data warehouse. Makes the data in your Aurora DB cluster available in Amazon Redshift or an Amazon SageMaker Lakehouse in near real time. So without doing any extract, transform, load, you can just get the data over there. You can power your analytics, ML, and AI workloads using the built-in capabilities such as machine learning, materialized views, data sharing, federated access to multiple data stores, and data lakes and integrations with Amazon SageMaker AI, QuickSight, and other AWS services. Okay, so I'm new to this, so let's check it out. To enable near real-time analytics and machine learning using Amazon Redshift on petabytes of transactional data from Aurora. Within seconds of transactional data being written into Aurora, the data is available in Amazon Redshift, eliminating the need for complex ETL pipelines to perform extract, transform, and load operations. So Aurora Zero ETL integration also enables you to analyze data from multiple Aurora database clusters in the new or existing Amazon Redshift data warehouse to derive holistic insights across many application or partitions. Okay. So Amazon Redshift provides near real-time access to transactional data and offers analytics capabilities such as built-in machine learning, materialized views, that's what we just read, or data sharing, federated access to multiple data stores and data lakes, enabling you to extract insights from transactional and other data. So Amazon Aurora Zero ETL integration with Amazon Redshift is now generally available in multiple regions. Okay. Amazon Aurora MySQL compatible edition 3, 3.05.0 or above, compatible with MySQL 8.0.32. Okay. We'll just get this in. I think we have this already. Okay. It's okay. We have this and we have Amazon Aurora. Okay. Cool. So in this lab, we'll complete preparing zero ETL source, target IAM permissions, set up zero ETL integration, validate zero ETL integration, delete zero ETL integration. Okay. So just a minute. Okay. Let me click next. Okay. So to create a zero ETL, just a moment. Alright. To create a zero ETL integration, you specify an Aurora DB cluster as the source. So that is the source, and a target as and an Amazon Redshift data warehouse as the target. The integration replicates data from the source database into the target data warehouse. Okay. So ensuring you're still working in the correct primary region, use Vesto, especially if you're following the links above to open the service console at the right screen. Before we get started, you need to prepare your source Aurora MySQL DB cluster. Aurora Zero ETL integration requires enhanced bin log, which are not enabled by default. You need to configure enhanced bin logs and other prerequisite parameters on the source Aurora DB cluster. During this section of the lab, we'll complete the following steps. Associate a custom parameter group to the Aurora cluster. Enable the following parameters in the custom parameter group: Aurora enhanced bin log 1, bin log backup 0, bin log format row, bin log replication global database 0, bin log row image full, row meta, yeah. Verify that binlog transaction compression parameter is not set to on, and the binlog row value options parameter is not set to partial JSON. Reboot the primary database instance in the cluster to apply the changes from the custom cluster parameter group. So configure the MySQL source, okay, with a customized DB cluster parameter group. Open the thing and zero ATL params, so parameter groups. So you'll have to go to the parameter groups. I think it's here. Just a moment. I think we're good here. We can leave this. So parameter groups, and then I think we are looking for zero ATL params. Yeah, and this is for MySQL 3 cluster params. Anyways, backtrack. Anyways, so interesting. I should look at these actually. Check out what these are about. Parameters. There are 423 parameters. Wow. Okay. Engine default, system default, modifiable, okay, non-modifiable, source, modified, system default. Interesting stuff. There are 400 parameters in this thing. Anyways, so here I'm going to look at this parameter group for zero ATL integration created from the RDS console. So yep, edit, and then you do what? Search for the required parameters and ensure the below parameters are set according to the documentation. Okay, so yep, that's the documentation. So let's look for enhanced binlog. So this is 1. Okay, binlog backup 0, binlog backup 0, binlog format row, format is row. Yep. Replication global DB, okay, replication global DB is 0. Okay, row image underscore is full, and row metadata. Okay, row image is full, row metadata is full, and then ensure that this is not set to on. It's basically, yep, it's not set to on. ZSTD is actually a compression library, and then this is not set to partial JSON. So I think this we saw already when we are looking at row metadata, row image, row value. It's not set to partial JSON. Cool. So for this is for Postgres. For MySQL, this much is enough. So we've done it, and it's already there. So and ensure the below parameters are set. Make sure the zip has been associated with the source database cluster before proceeding to the next step. Okay, so basically, okay, focus mode. Wow, okay, that's nice. Cool. So to do so, click on databases, select Aurora, okay, and databases, Aurora MySQL cluster. And click modify database options. Okay, modify database options, parameter group, and zero ETL. So click on continue, apply immediately. So continue, apply immediately, and this should happen now. Ideally, I don't know if it requires a restart. So has been successfully modified. Okay, let's see. So in order for the above DB cluster parameter group changes to be applied to your Aurora MySQL cluster, we need to reboot the cluster writer instance. In your configuration tab, writer, you will see the status of the parameter group changing from in sync to applying for about 30 seconds. Okay, so writer instance configuration in sync. Okay, this is not for that. parameter group, instance parameter group. Okay, instance parameter group. Okay, applying for about 30 seconds, and then it will become pending reboot. Okay, so it will come up as pending reboot I think. So we have to reboot. Until it has a reboot, I think it won't be done. So to reboot the cluster, select your writer instance, click on actions and click on reboot, and then click on confirm. Okay, cool. So once you reboot, you can observe that DB cluster parameter groups is in sync status. Okay, cool. So let's look at that. So here parameter group, parameter doesn't say much. DB cluster parameter. Let's wait for this thing to say pending reboot, and then I'll actually just reboot it up. I want to see, okay, pending reboot, awesome. So can I click this and then say reboot? No. Is there a reboot option? No. So this one has a reboot option, I think. So yeah, reboot. Yes, I think that was the writer instance. Yes, as the writer instance, it's rebooting. And configuration, pending reboot is there. Cool. Once this is done, I think prepare 0ATL target. Okay, let's see if this reboot works. Rebooting. Okay, so the data is replicated to the Amazon Redshift data warehouse. There are two types of data warehouses: provisioned cluster data warehouse, collection of computing resources called nodes, which are organized into a group called a cluster. Serverless data warehouse, work group that stores compute resources, and a namespace that stores the database objects and users. Interesting. So just a moment. Okay, this is available, and this says, let me try to do a refresh. It doesn't say in sync yet. Okay, let's see. Okay, now it is in sync. So you can actually see it. And for the writer instance also it is in sync. Cool. So now we'll now prepare our target Amazon Redshift data warehouse with the following requirements. Create a target Amazon Redshift data warehouse using either a RA3 node type, that is RA3.16x large, RA3.4x large, or RA3.XL plus, or Redshift serverless. Ensure it's encrypted if using a provisioned cluster. In our lab, we have created a provisioned cluster. So configure authorization for the data warehouse. Okay. So this add authorized principal, the user or role that can create 0ATL integrations into the data warehouse, and configure the source Aurora DB cluster as an authorized integration source. The source database that can update the data warehouse. Enable case sensitivity on the data warehouse. Okay. To prevent data issues, the target case sensitivity parameter needs to be enabled, since Aurora MySQL and Amazon Redshift have different default settings regarding case sensitivity. Okay. So provision cluster dashboard, select the ZETL RS cluster. I think RS is something like a resource and Redshift, yeah. Redshift console. Okay, Redshift cluster, which is provisioned for this lab. So for some weird reason they have a hyphen at the end, and they say they don't allow two hyphens at the end, or even two hyphens, consecutive hyphens, and they don't allow hyphens at the end, but this one no. List snapshots, list recovery points, list work groups. Okay, these I don't have access. Okay, to keep up with these changes, take actions, critical updates. Okay, see behavior changes, features in preview, create preview cluster. Interesting. Choose preview track. Okay, so I'll just look at Amazon Redshift. So introducing IAM Identity Center integration with this. Okay, to query Amazon Redshift and perform other tasks across different AWS services. Oh hey, well, I can just check this out later. Cool. So now I'm gonna actually look at the one total nodes, on-demand nodes, reserved nodes. Okay, so I'm just gonna click this and click resource policy tab, add authorized principals and authorized integration sources. Okay, resource policy, general information and all that, endpoint and all, resource policy. So add authorized principals and authorized integration sources. Okay, so principals. So for authorized principal, enter either the Amazon resource name of the AWS user or role or the AWS account ID that are allowed to create integrations in this namespace you're working in, and paste the IAM principal or IAM and click on save changes. Okay, so I think this will be this one. So account ID, right? Save changes. Okay, and then what is that? If successfully, okay, but it becomes yellow, I think, for some reason, or is it? Anyways, you can now register table definitions. Okay, Athena. So EMR serverless. So you can now register your Redshift table definitions to AWS Glue data catalog, making them accessible from other query engines such as EMR serverless, Athena, and other Redshift data warehouses. To get started registering a namespace, select Redshift provision cluster from the clusters and then select register with AWS Glue data catalog from the actions menu. Okay, and query editor v2 provides new features such as multi-statement query execution, query parameterization, query versioning, visualizations, and query sharing. Okay, I'll come to this thing later. That is Redshift stuff, and this is query editor v2. Cool. So I think query editor v2 is basically this. SQL workbench. So as work groups couldn't be listed. Names is fine. Now suppose Amazon generator. Cool. So I'll come to this later maybe. So now we have the account ID here. Add authorized user and source. We need to add the from the RDS console. Select cluster. Click on configuration. Copy the thing. Okay. I think this is the thing. I want the Amazon resource name. Click the configuration. Okay, so it has to be this, right? It shouldn't be the node 1 or node 2. It should be the cluster. So yeah, RDS and cluster, and then Aurora MySQL cluster. This one is DB. So this doesn't say cluster, it says DB. So it's not cluster, is DB, and this one is the cluster. Okay, cool. So save changes. Yep. And now learn more. I think this is just the old one. Yeah. Cool. So let's Close this up. So once we've done this, we have this and this. Update the Amazon Redshift parameter group to enable case-sensitive identifiers. For a successful integration, the case sensitivity parameter must be enabled for the data warehouse. To enable case sensitivity on a provisioned cluster, create a custom parameter group with the parameter enabled, then associate the parameter group with the cluster. Configurations on the left hand side of the thing. Configurations, okay. And workload management. Choose workload management, and then create parameter group. Okay, parameter group name is this, I think. Enter the name 0ETL parameter shared. Okay, so 0ETL param redshift, and then custom resource parameter group for redshift target. And then create this. Was created. Okay, and then choose the newly created parameter group and click on the parameters tab. Edit parameters to true and save the parameter group. Okay, so edit. So click on the parameters, edit parameters, make it true, and that's it. Save. Cool. So that is it. So we have it as true. So and then now associate the parameter group to the provisioned cluster, the Amazon Redshift provisioned cluster. Navigate to the provisioned cluster dashboard and click on this Z cluster. Click on the properties tab, edit parameter group, and then okay. So serverless, not serverless. This is basically all denied. List work groups, describe on-time credit, list namespaces. So anyways, serverless dashboard, query editor. Anyways, I think I need to go to Redshift. How do I go back to Redshift? Provisioned clusters dashboard. Yep. Cool. So cool. So provision clusters dashboard, we have click this, and then click edit. I think we have a parameter group here. There must be a configuration here. Properties, parameter group. Yeah, here it is. So edit, go to edit parameter group, or just click edit, and then you can actually edit the parameter group, I guess. Here, database configurations, parameter groups, on the cluster details properties tab. Yeah, so open the tab. So here you can click the parameter group, and you can choose this and save it. Cool. So this is done. So close this. Yep. So we've done it, and now once the status of this is changed to available, so it's modifying as of now. So now when it's available, reboot the cluster, click on actions, reboot, and then reboot the cluster. So we have now prepared our source and target for 0ETL integration. In the following lab, we'll examine the required permissions for the integration. Okay, let's just reload, refresh the page. So it's available now. So you can now this is the data. There are 14 parameter changes to the parameter group that require reboot. So you just reboot this. Basically here it says this, yes, but it requires a reboot. So you just click the reboot. You're about to reboot the following cluster. Any currently running SQL operations on this cluster will be cancelled. Are you sure you want to reboot? Yeah. Cool. We've done it. I think we've rebooted. Is pending reboot, so it still says pending reboot for some reason. but it says modifying also. Pending reboot, databases, data shares, cluster details. Yeah, it was rebooted. Cool. So I think I don't have to click reboot again. So it's a RA3 4x large. That's pretty big probably. So to create a zero ADL integration, so CFN stack has already, so the cloud formation I think has already provided you necessary privileges for creating zero ATL integration to any zero ATL destination. Configured required permissions using IAM. To create a zero ATL integration, your user or role must have an attached identity-based policy with the appropriate AWS identity and access management permissions. IAM, that permissions that is. The policy allows the associated principal to perform the following actions. Create zero ETL integrations from the source Aurora DB cluster. View and delete all zero ETL integrations. Create inbound integrations into the target data warehouse. This permission is not required if the same account owns the Amazon Redshift data warehouse, and this account is an authorized principal for that data warehouse. We have already created an IAM role for our lab. Navigate to the properties tab and scroll to cluster permissions to view the associated IAM roles. Okay. So let's see if this is still in that status. Let's see. There's a lot unavailable. It is okay. Is it? Wow, it says unavailable for some reason. I'm not sure what to do now. As we heard, and it has 244 TB. Wow, that's a lot. And was rebooted. Completed restart. Begin restart. Okay. 0 errors. 10 total events. So it was restarted. Completed restart. Was rebooted. So there are some events. So these are the different kinds of events, I guess, that you have. Okay. So that is 300, 3520 and whatnot. 3519, 1000, 1005, 1003, 2000, 3520 again, 3519 again, and 31003 again. Yeah, again only. So what is wrong here? So it says unavailable. View all clusters. Cluster unavailable. So resize reboot. Let's see if that can help it. Completed reboot, was rebooted at this time. I want to see events again. It says modifying as of now. 256 TB. A few seconds ago it was rebooted here. Let's see if it works. Rebooting, modifying, rebooting. Yeah. Let's see if this happens correctly. Once you have this, I think the properties should say this ETL parameter, Redshift, and all that, and it should say it's working, it's available. Let's see. Associated IAM roles, Redshift serverless immersion role. Okay. These are associated. Okay. So properties, cluster permissions, Redshift server, not serverless, server immersion role. This one is serverless. Okay. But anyways, server immersion role is what we are looking at, I think. So let's see if this is still available. The status is still unavailable. Oh my god. That's problematic. There's no monitoring of sorts, is it? I don't know why this is not working anymore. That's weird. Can we stop it or pause it or delete it? Anyways, pause. Pause now. Okay. So it's pausing. Let's see if that works. And then we will resume, I guess. Let's see how that goes. Cool. So we have seen the permissions. If you wish to customize the IAM policy, you can follow these steps to configure the necessary permissions on the cluster. Okay. So I think this is still in modifying state. Okay. And finally, we zero integration, ETL integration. With your source and target prepared, you can create a Aurora zero ETL integration using the AWS Management Console, AWS CLI, or RDS API. For our lab, we'll create the Aurora zero ETL integration from the AWS Management Console. Choose zero ETL integrations in the left. Okay. Is this available finally, or is it in paused state? Something. It just says modifying. That's not helpful exactly. Yeah, it's paused finally. Now I can resume it. Resume now. And then I'll also reboot it maybe. So here we can say zero ETL integrations, new. Source database and target data warehouse to be configured correctly. Source database and target data warehouse. In addition, the correct permissions must be set for the target data warehouse. So zero ETL integrations, yeah. Cool. So I think prepare source database, parameter groups. Go to Redshift console, create zero and so cancel. Basically here click and then enter integration name for your integration, Aurora zero ETL, and description is zero ETL integration. So zero ETL integration, click next. Let's see if it's resuming still. And then next, browse RDS databases, or we'll just say MySQL cluster. Oops, should have chosen this like this. Customize data filtering options. Amazon Redshift data warehouse. This one resuming, that's fine. I want it to be available basically. Let's see if this is available. Resuming, modifying, resuming. This is still unavailable for some reason. I'm wondering, should I actually create something on my own and see if that works out? Yeah. So, or edit, audit logging, edit port. It just says unavailable. Query monitoring, resume policy. Logs. So it says create an IAM role as the default for this cluster that has the Amazon Redshift all commands full access policy attached. This policy includes permissions to run SQL commands, as to copy, unload, and query data with Amazon Redshift. The policy also grants permissions to run select statements for related services such as Amazon S3, Amazon CloudWatch Logs, Amazon SageMaker, and AWS Glue. So let me check out if I'll have this. Yes. Let me check out if I can actually find out the CloudWatch thing. CloudWatch, not CloudWAN. CloudWatch, and look at the status of our Redshift thing. For some reason, it's unavailable. Deregister, cancel. I don't know what AWS Glue data catalog is anyways, but backup and disaster recovery, restore table, relocate, versioning, resize, reboot, pause. I've been trying to reboot, but it's not working at all. I need to understand what is going on here. Log groups. I think I need it for Redshift. Shift 0 ETL. All metrics. ETL. Redshift. Node metrics. Cluster identifier. I want logs, by the way. There's nothing for Redshift, is it? Interesting. This is still unavailable. Okay, let me actually just still go ahead with this. And should I say encryption? No, let's just go ahead. Okay. Cool, so so it can take a lot of time apparently for the thing to be active. So after a few moments it would be in active state. Create destination database in Amazon Redshift. So to finish creating a zero-DL that replicates data from Amazon Aurora MySQL into Redshift, you must create a destination database in Amazon Redshift. The destination database must include a reference to the integration identifier. You can use the Redshift console or the query editor to create a database by using the following steps. So 0ATL, query in query editor to basically query monitoring, cluster details, query data, query in query editor v2. So this is v2, and so here on the configure account page, no changes are required. Click on configure account. If you see an errors, close them. To connect them to the click on it. Under ways to connect, choose AWS Secrets Manager. Okay. So AWS Secrets Manager, choose a secret, this, create connection. I don't think it will work because this is unavailable. Oh, this works. Wow. For some reason it says unavailable, but everything seems to work. Okay, that's interesting. Okay, so click on the secret and you should be able to go create connection. Once there, select integration ID from SVB integration. Okay, this. Run, and you should see the integration ID here. No rows. Okay, weird. I think you have to choose the database first. So it says AWS data catalog, dev, sample, z, ETL, native data. Okay, I wonder if SVB integration, public. Interesting. So I don't have that. So once connected, run the following query to obtain the integration ID for our destination database on the Redshift cluster. Cool. So reboot. Not available. You're not able to reboot. Okay. Wow. Should I just delete this? Can I create? I'll choose the size of, help me choose. Clusters. RA3 4x large. How big is this? It says modifying, integration creating, okay. Oh wow. Looks like something is happening actually. I don't know. It says RA3 4x large, okay. That is a lot of thing. Okay, and that is 128 TB and per node, and we have 2 nodes I think. Number of nodes is 2. And okay, so if it's 1, then it's going to be this, and it's going to be this. Wow, that's a lot of money. Load sample data, admin username. I don't think I'll have access to create this. To start using the query editor to query data. So let's see if this is being available or not. Cool. Okay. Username. Integrations. Creating no database. To create a database, go to the integration details page and choose create database from integration. Connect to database. Stream mode keeps track in the integration target which records in the integration. So which records in the integration source were deleted or changed. Okay, that is interesting. I mean, it has some history stuff. Anyways, wow. So this is sending transactional data to the Amazon database. State is no database. Doesn't have a database. I created this. Source is Aurora MySQL and the MySQL cluster. Target is this. Database, I'm not able to get it because it doesn't exist, or I don't know. Yeah, and I don't know if I should actually be looking at provisioned cluster dashboard, clusters. This is in modifying state, integration creating. So I think it's creating the integration. So we probably created in some time, I think. Let's see. And cool, I think I might have to just skip this for now and copy the integration ID from the previous step and insert into the below query to create a new database for the integration. Make sure there are no additional spaces when you run the below query. So create database, Aurora _ 0 integration, run integration, this refresh symbol. To view your new database, the integration is now complete and an entire snapshot of the source will reflect as is in the destination. Ongoing changes will be synced in near real time. So, okay. Is it in unavailable state or... Oh, it's in available state. Wow, okay, great. So now I can actually run this, I think. Wow, okay, we have this now. I think there was some temporary error. Anyways, we can copy this, I think. Wow, can I click this and copy rows? Okay, so okay, so now I can actually check out this thing. Wait, previous. So once you get the thing, okay, basically put it in this. I don't have to create one more thing. Okay, and this integration ID, yeah, and run this one. Okay, result 2. This is created, and if you refresh now, you should have. So now you can see green over here, native database for Aurora 0 ETL, awesome. So graviton test, you can actually see all the SB 0 tables, no? Interesting. Okay. So I think it should come in sometime, the tables, SBT, PCC, I don't know. And so open this up. Yeah, now tables are available already. So you can actually see the whole SB test 1, 2, 3 and all that, right? So you can actually see these, right? And you can actually say the select start from and run it, and it'll show the whole thing. Limit is 100 and then explain. So you'll actually get 100 over here. No. Oh, I think it's still copying. I think it's probably still copying the data, so it's probably that's why it's not showing up. Anyways, views. So in my lab there should be some tables, I think. So one table, yes, SB test 1, and select table. So I think we have many tabs. Oops. Close this. Close this. Close this. Okay. Okay. Yeah. Now it's showing up data. So yeah, now the data is coming up, and I think here also it should show active. Yeah. So destination type, destination ARN and all that. And if you open this up, it should show data warehouse and all that, the cluster, and the database inside this. I think interesting. Integrations, it should show one integration and needs attention. If for more information, navigate to the integration details page. Okay. Primary key not found. One or more tables don't have a primary key and can't be synchronized. Add primary keys on the table missing primary keys. The integration will synchronize them later. Okay. Okay. Table statistics. Okay. Cool. So looks like one of them has some issue in the primary key. So anyways, validate 0 ETL, needs attention. Create a database and learn more. How was your experience creating? Provide feedback. Cool. So you can actually see it says needs attention. Create a database. So I think integration SVV into underscore integration. Yep. So this and this. Anyways, so this one, the integration will say if the problem persists. So looks like they don't have primary key and can't be synchronized hence. So in this section we'll establish a database, load data into the source Aurora MySQL DB cluster, and then verify it on the Amazon Redshift cluster after replication. If you've not already opened the terminal, yeah, okay. So we have the MySQL hash thing. Yeah. So we won't be connecting to the MyLab thing. Instead it will just be this. So it will be MySQL. And we'll just take this to here, and here we'll say create database, if not exists 0 ETL, create table users. So we have all these create. We're gonna load the data, I guess, in this SQL, all of this. So let's create this one by one. So let's see how this goes. Okay. And then load data. So let's just load this data. Sales is the last thing I think here. Cool. So we have all the data done. Okay. So this basically has to be done too. Yeah, and then finally toggle to the browser menu which has Redshift query editor open, which we used in the pre-order lab. Connect it to the Redshift cluster. Run the following query to validate the source changes are being replicated to this. So query editor. I don't have any tab open, so let's just open this. Run. This is all available. This is all good. I think the integration details, primary key not found is one problem. Here you can actually see Aurora 0 ETL is the target database, checkpoint name, right, and then checkpoint bytes, start time. Can you put these like this? Oh, start time and time. Okay. Change this. Okay, so here you can actually see this. So what are all these tables? Has system tables and views that contain information to monitor Aurora 0 ETL integration. You can query the following system views and tables to get information about your 0 ETL integrations. So SVV integration provides configuration details for your integrations. Okay. Table state describes the state of each table within an integration. Displays table state change logs for an integration. Provides information about completed integration runs. So modified tables 7 and 1, so you can actually see the modified tables thing here. Modified tables 99 7 4 3. Okay, interesting. So let's go here and okay. So run the following SQL query which checks the count in the target database Aurora 0 ETL created from integration. So this one we're gonna run it here. So this, we have one more editor. That's a notebook. I think it's a Python thing, I think, or similar to Python notebooks, interactive notebooks. Anyways, control space for autocomplete, and so let's run this. Let's see how that goes. So we have this listing, sales. So we have listing, venue, so sales, date. So row count is this much. So we should look at that. 192 497, 172 456. Yeah. And then 49 990, 8 798, 365 202, and 11. Wow. Table name took count star, and then this format, I guess, as row count. Zero ETL, date, listing, venue, sales. Interesting. So this has Aurora 0 ETL, and there's a 0 ETL thing. Inside this, I guess there are many tables. Yeah. Category, for example, has 11. Let's say listing has so many. Cool. So we can confirm that the data has been replicated to Amazon Redshift target from the Aurora MySQL source. Monitoring. In order to view the integration related metrics published to Amazon CloudWatch, navigate to Amazon Redshift console. Integrations integration ID links to display activity metrics. So here, zero ATL integrations. Status needs attention. Write integration ID links to display activity metrics. So I think the integration ID comes up here. Integration name, okay. Integration metrics. Large 0 tables replicated is 97. Tables failed 9. Okay. Integration metrics. Table replication success of failed accounts and lag details. Click on table statistics, which provide details of each table replicated from Aurora MySQL to Amazon Redshift. Okay. So I think this one is also the same thing. Okay. These both are the same thing. So I'm just gonna go ahead and you can close this. And you can actually reload this to see the error primary key not found. So the integration will resynchronize them later. So add primary keys on the tables missing primary keys. So some of our tables miss primary keys. So last 1 hour or last 3 hours, and doesn't show anything. Not show anything. So it doesn't show anything when you say 3 hours. Anyways, last hour it shows table statistics. So it says all table statuses synced. So for complete reference on this, visit documentation, Amazon Aurora and Amazon Redshift. Yeah, 0ATL. I think this we have already done. We don't have it here. And then this, and then this. Okay. So cool. So I think table statistics, I think we can't see it here. So for some reason, connect to the database. I think temporary credentials, Redshift, cluster not found, database name is use a recent connection, temporary credentials. So Redshift, database name, maybe we can actually mention maybe 0ATL as the database name, or should it be that integration ID that we got? I don't know. Let's see, maybe just Aurora 0ATL, right? Connect, execute statement. So you don't have permission to request access. Okay, so you don't have permission to connect to the database and see the table statistics. Okay, cool. So dropped source, nope. So we can't see anything, but it's okay. You don't have change connection. We don't have any way to look at the table statistics, so it's okay. And it's finally, you can just clean up the resources, delete Amazon Aurora 0ATL integration with Amazon Redshift. You've created additional AWS resources. We recommend you run the below commands to remove these resources. Once you've completed these labs, follow below steps for a quick cleanup. Delete the 0ATL integration created as part of this workshop named 0ATL serverless. Follow the steps below for deletion. So, okay, this is the one. I think you just have to click this, and Okay, so we have to go to the RDS and then zero integrations. Click this and then say delete, confirm, and then delete. So alternatively, if you wish to delete anything, run the following commands after connecting. So yeah. So I think that's it. So this is in deleting state. So this is confirm. Yep, it is in deleting state. So now if you just reload or yeah, so it can't be deleted now hereafter, and this we can close, I think, and this should not show anything. Yep, and here you're good to go. I think CloudWatch, you can check out some things. Integration metrics. So navigate to CloudWatch. I don't know if the metrics. I'll have to look at metrics, all metrics. Look at this is Redshift, cluster identifier, integration ID. Okay, so that's the integration ID. So Redshift, node metrics, there's a lot. Cluster identifier, query type, latency, query priority, node metrics. Anyways, so finally we've cleaned this up, and after cleaning this up we can actually do, I don't know, we still have upgrading Amazon Aurora MySQL DB clusters, Amazon Aurora serverless, machine learning, and global database stuff, and database activity streams, and IAM stuff. This is over, so I'll just close this up. This is also over. Close this up. Let's probably upgrade, right? So you can upgrade an Aurora MySQL DB cluster to get bug fixes, new Aurora MySQL features, or to change to an entirely new version of the underlying database engine. The following labs will show how you can use different options to upgrade the engine version for your MySQL clusters, Aurora MySQL clusters. So major version upgrades and minor version upgrades. So major version upgrade with blue-green deployment. In an Aurora MySQL version number such as 3.0.09.0, the 3 represents the major version. Aurora MySQL version 3 is compatible with MySQL 8.0. Aurora MySQL version 2 is compatible with MySQL 5.7. See checking Aurora MySQL version numbers for more information. Upgrading between major versions requires more planning and testing than for a minor version. The process can take substantial time. After the upgrade is finished, you also might have to have follow-up work to do. For example, this might occur because of differences in SQL compatibility or the way certain MySQL related features work, or it might occur because of differing parameter settings between the old and new versions. So in this section of the lab, we'll perform the major version upgrade for an Aurora MySQL cluster using Aurora blue-green deployments. My god, my tongue is rolling up a lot. Version, I was saying version instead of version. Anyways, creating a blue-green deployment. So to create a blue-green deployment, assign in, and then databases, upgrade. Okay, so I think we have RDS. Oh, interesting how this said database migration service. Anyways. Okay, so here we can go to databases. So there is one thing called upgrade cluster, I think. So click on actions, choose blue-green deployment. Okay, actions, create blue-green deployment. Is it new? This is a new thing, is it? So you can also do this here, I think. Create blue-green deployment. Okay, page appears for identifier blue-green upgrade BG. What is BG? Blue-green. Okay. So blue green deployment name. So let's just get these out. So yep, so this is here. So under choose the engine version for green databases, select the Aurora 3.082 version. Okay, choose the thing as this. Okay, version 3.08. So blue engine version is this. Green is 3.082. Okay, 3.082. And cluster parameter group is CPG cluster parameters. Okay. Params 3bk something. Okay. Okay. I don't know what's the difference between these two. Okay. For green database and parameter db cluster parameter group, and then this is okay. Cool. So now we'll click next. So scroll down and click on next. I'll actually go ahead and look at these parameter groups. I want to see what these mean. What's the difference between this one and this one? Cluster params. This is for the backtrack. Okay, BK. I don't know why we need to use this. The backtrack one. We can just use this or this. I don't know. This is for 8.0. You can use any of these, I think. Anyways, what's the difference here? I don't know. Can you find the difference between two parameter groups? Actions, compare. Yes, thank you. So the only thing is, in the backtrack one, there is something called max prepared statement count, and that is nothing. And here it's actually this. Cool. So nothing else, by the way. So yeah, and for this I think there will be a lot of differences probably. Compare. Yeah, a lot of differences. So you can actually see each parameter and what is the value, or if there's no value here. Cool. So let's close this up, and the default, yeah. So this is DB instance and then DB cluster. We can use this also actually. Can we? We can't compare those. Okay. So can we create one out of it? Out of this? No, I don't know. Can you create a custom parameter group, engine type, MySQL 8 type parameter group? Test, create, test. Interesting. If I check, okay, this is for DB instance. Okay, I can delete this. If I create for cluster parameters and then say 8.0 MySQL test, you can have hyphens at the end, and you can't have two consecutive hyphens. So I think if you have two consecutive hyphens, yeah, it'll be an error. Cool. So test and create. So let me compare this with this to see what's the difference. There's a lot. Okay, so test one doesn't have anything. This one, default S3 role, it has one, and to be able to, I think, download from S3, I think. So InnoDB stats, persistent sample, long query time, prepared and all that, and then slow query log. Okay, cool. So anyways, now, Scroll down and click on next. You can optionally also choose to create the green environment with the same database version as your primary blue environment. Okay. uh, for the purpose of this lab, we are creating the green environment and then upgrading it uh, to one of the latest versions as part of a single step. So observe your changes in the review screen and click on create. So it just says this upgrade node 1 node 2. Oh hey. Oh hey. Cool. So 3.08. Oh hey. 8.0. Oh hey. 20 to 25 minutes for the green environment to be available. This concludes this task. Please proceed to the next module to view and connect to the blue-green environments. Okay, so I think I'll just create this up for now. So this is the connection overview and deployment. So you can actually see hide readers, show readers and writers, writers, green, right? Replication. So all of this, and then blue-green deployment name, and then what is the difference, right? And then finally so replication also happens, and then you can create to ensure that IAM policies are applied before switchover, aren't copied over from the blue environment to the green environment. Make sure that your IAM policies are appropriately applied to the green environment before you switch over to them. Okay, so create, and I think can I find a BG here? Oh yeah, it's getting created. Click view details. So this is the one, resource ID. So I think you'll notice these over here in the dashboard. Okay, so I don't think you can find it in the databases. BG. Oh, you can. Cool. This is the green, this is the blue one. Provisioning, this is available. Replication, security group rules. Cool. So here you can find the blue one, here you can find the green one, right? Click here and you'll find the replication and all. Cool. So let's just click this and let's just wait for this to come up. So this one is already available. So oh yeah, because this is part of that. So this one, it's being created. So yeah, you'll notice these getting created. So in this section of the lab, we'll view the settings for the blue-green deployment that should now be in available state. We'll also create an example table and load data into it and verify how it is getting replicated to the green environment. This module requires these creating we created. Each tab has a section for the blue deployment and a section for the green deployment. In the connectivity and security tab, copy the endpoints to connect. Okay. Cool. So looks like these are in progress. Creation of the source. Close. You can actually see view details. Creating green DB. Read replica. TV engine version upgrade. All of it is here. So rate your experience, it's good. Right. Okay, so we can actually close this. So this one, it still hasn't shown anything for green yet. For logs and events, configuration for blue source, for green it has to show. So this is still creating. So yeah, if not already opened thing, once connected to the database, okay, so we are already connected to the database. Let's connect once more, and you can run this and complete it. You can quit. So once you run this, no database selected. No database selected. Okay. I think it has to be MyLab. Sorry. So we have to get into MyLab and then paste this. Yep, done. Cool. So now we have this ready, and we can also just copy this and put it here also. SQL. Yeah. So when completed, quit, and then now to connect to the green environment, follow step 2 above and copy the endpoint to connect to the green environment. Okay, so I actually connected to the not the blue-green thing. So I connected to the other one. I need to connect to the blue one. Connectivity endpoint is this. So upgrade cluster. Upgrade node 2 is, I'll go here and I'll just say this, and so -h this, and then this, and then close it up, and we're good to go. So we don't have any green deployment yet, so we'll have to just wait, I guess, until we have that, and then we can check out how that looks like. So copy the endpoint and replace it, and then check show tables optional. This concludes this section. Please proceed to the next module. Perform a switchover once all changes have been validated. You can also examine other details for both the blue and green environments to see the details and difference between them. For example, check the configuration tab to verify the DB engine version. You can also check the logs and events tab to see the events generated while creating the deployment. Interesting, yeah. So logs and events. Nothing showing up here. Oh, here. Yeah. Anyways, CloudWatch alarms. Interesting. What about this? So it just says syntax secret auth is deprecated, started in read-only mode, punch hole. Interesting. So there's a lot of stuff. So just go here and open up these, and we'll see actually that okay, a lot of them are not much. Anyways, cool. So now I'm gonna just check out how the switchover happens. Promotes green. So to be the new production environment, in this section of the lab we'll switch over to the green environment, making production. Aurora bin log replication lag in the CloudWatch metrics. To reduce downtime, make sure that this value is close to 0 before you switch over. So database connections, use this metric to estimate the level of activity on the blue-green deployment and make sure that the value is at an acceptable level for your deployment before you switch over on both blue and green deployments. Type DB connections into it, and that you created, click on switch over, And you're done. In the switchover page, please review engine versions and the switchover timeout option. Between 30 seconds and 3600 seconds, 1 hour. If the switchover takes longer than the specified duration, then any changes are rolled back and no changes are made to the either environment. 300 seconds, 5 minutes for this lab. Once you're ready, choose switch over and verify the status. So switching over, and now the green environment will become the production environment. The bin log replication setup between the primaries for blue and green environment is revoked. RDS renames the DB cluster and the instance in green environment to match the corresponding DB instance in the blue environment, and blue environment gets tagged with old n, where n is a number. Interesting. This concludes major version module. You can proceed to minor version upgrade. Oh hey. So let's see if green gets created. It hasn't been created yet. You can view the details. You can probably open it in new tab, and yeah, so this one is still in creating, so let's just come back to this later. So this one, upgrade required. Yeah. So basically version 2 is auto enrolled into RDS extended support and all that. So basically this is a problem, and hence we are trying to upgrade, right? Cool, looks like this is available. Interesting, it says available. View details. This succeeded, created green DB. So this is in progress. Okay. Can you connect to this then? So can you say something like -h in this? Okay, as of now it's not known, so I don't think so. You can't connect to it, I think. So this one, I think it was okay. This one was basically upgrade cluster and all that, or you just connect to node 2 and all. And this one, I think it's still getting created. It's not, status is creating. So these they've been created already. Yeah. So once this is created, I think we'll be able to access. So let's just check. So let's look at my minor version upgrade till then. So looks like even one node got created, or it's getting created, and this is status creating. Oh yeah, cool. That's pretty cool actually. So you can actually see close. Yeah. So for minor version upgrades using in place upgrade method, basically you just in place upgrade it. No blue green deployment, I guess. Once we are done with this, I think it'll be serverless, machine learning, and global database and IAM stuff. I think serverless next, and then machine learning is next, and then global database is going to be pretty big, I guess. And then remaining should be easy. So upgrading the minor version of an Aurora MySQL cluster applies additional fixes and new features. So basically minor versions, you have minor new features and all that to an existing cluster. So there are also fixes. So this kind of upgrade applies to Aurora MySQL clusters where the original version and the upgraded version are both in the MySQL Aurora MySQL 2.x series or both in the 3.x series. The process is fast and straightforward because it doesn't involve any conversion for the MySQL metadata or reorganization of your table data. In this section, we'll perform the minor version upgrade for an Aurora MySQL using in-place upgrade feature. So we have an in-place upgrade feature. So in place, this lab will walk you through the process of performing an in-place minor version upgrade. An in-place minor upgrade can be performed by running an upgrade process on the cluster itself, same cluster itself. Okay. So this technique keeps the same endpoint and other characteristics of the cluster. The upgrade is relatively fast because it doesn't require copying all your data to a new cluster volume. While performing the minor version upgrade, you can choose to apply the modification with apply immediately or apply during the next scheduled maintenance window setting. To perform a minor version upgrade, go to this. I think you will say Aurora Lab UPG cluster. Okay. So I will open this up. So okay, I think we'll have to use the same one, and until this is not done I can't do that. Or can I? Maybe I can. Just click on modify DB cluster, page appears, 3.09, scroll down. Okay. Let's actually do that. Go. So click this, and then actually say modify actions. Modify. So okay, this is actually 2.12. Okay, so I think this can't be done. Cancel. So, and this is 2.12 is the latest, I think. Oh no, there is 2.12.5 also. We can do this if we need. So yep. And here you can actually see 8.0.40 and all that. Anyways, we'll cancel this for now. So let's actually try to wait for this. Configuring log exports, great. Modifying, I think this is going to be available. Oh, this is already available. You can actually see this. So let me try to access this. Oh yeah, I'm able to access it. And show databases. Yeah. And then connect to MyLab. And then show tables. Select star from labs. So replication is set. Yep. This is good. You can actually see that the replication is set because that's what we know from the whole UPG cluster that we just did. So I think it's good. It's actually configuring log exports. So this should be available in some moments. Configuring enhanced monitoring, I guess. Yep. And then let's just immediately switch over because I don't have anything to do. I'll just switch it over. And this one, I think it's already having a endpoint and all, so it should be pretty cool, pretty straightforward. So we can also connect to this if needed. And -h this. Great. So MyLab, select star from MyLab. Yeah. Cool. So let's go here. Let's go here. Reload. And get this done, and then so you just need to modify this and then apply immediately, and then the cluster will now be in upgrading status. So which would take a few minutes to complete. After the upgrade is complete, you can verify the engine version change by navigating to the configuration section of this cluster. This concludes this module. Okay, cool. So I think minor version upgrade is pretty straightforward. Let's look at serverless. Okay, machine learning and then global database. Okay, cool. Let's look at this. So Amazon Aurora service. We'll it's in modifying state. Interesting. Anyways, I will close these. I think this one I'll leave it because it shows me the progress. I'll probably open this again here. Cool. So Aurora Serverless V2 is an on-demand auto-scaling configuration for Amazon Aurora. Amazon Aurora Serverless V2 helps to automate the processes of monitoring the workload and adjusting the capacity for your databases. Capacity is adjusted and automatically based on application demand. You are charged only for the resources that your database clusters consume. Thus, Aurora Serverless V2 can help you to stay within budget and avoid paying for computer resources that you don't use. So this is all true, but if your database is being used a lot, it's better to just have a server-based thing and not a serverless-based thing which auto scales. So if the CloudFormation has provisioned the database cluster on your behalf, then skip this section and proceed to gather cluster details. I want to create. So to create, you need to go to the service console if you don't already have it open, and then create database. And the first configuration, create database, standard create. Next engine option, you have to choose MySQL compatible engine version and enable show versions that support serverless v2. Ensure that the version 3.02 is selected under available versions. Okay, production. And then the settings section, set the database cluster identifier to Aurora lab MySQL serverless v2. Configure the name and password of the master database with the most elevated permissions in the database. We recommend to use the username administrator for consistency with subsequent labs and password for your choosing. For simplicity, ensure the checkbox auto-generator password is not checked. Okay. Select serverless instance configuration. We are going to choose serverless under DB instance class, which would populate serverless v2 as the DB instance class. Under capacity range, so basically if you go look at this, oh, there is 40% now. Wow. Replica read, replica creation of the source. It's created. Great. So it's upgrading now, by the way. What does this mean? I don't know. Configuration, currently the engine is 5.7. So it should upgrade to 8 point something, I think. So okay. So the version for this is also 5 point this. Okay. Okay. So it upgrades. Okay. Cool. I think we do this in one go. We can upgrade it separately also. I think modify and then just upgrade it off. One moment. So you can't change it. Okay. Currently you can't change it. Yes. So here it says 20%. I don't know why. Anyways, oh, now we have green coming up here. The endpoint and all. Monitoring will be there for both, I guess. I don't know. Logs in events, green, and then blue also will show up here. Recent events, and there are many pages. You can see green's thing also. Cool. So recent events. Cool. So I think the idea is to basically over here, if you notice, in major version upgrade, they say create a blue-green deployment, right? So when you do this, I think so when you do this, you're basically saying the green instance, the configuration is 3.08. You can optionally also choose to create with the same database version as your primary blue environment. For the purpose of this lab, we are creating the green environment and then upgrading it. to one of the latest versions as part of a single step, right? So in one step itself, we are doing that. Observe your changes in the review screen. So first it will create with the same version, and then later it'll upgrade. But you can upgrade it like in two steps also, I guess. So here you can see versions, right? So yeah. Anyway, so now we'll go back and look at serverless stuff. So let's try to create a database over here. Maybe over here, create database, restore from S3. No. So here MySQL compatible, standard create, engine version. Engine version we can choose, I think 8. So 3.02, I think. So while creating, you have to say enable this. Okay. You need to say MySQL compatible. Okay. You need to say show versions that support engine version. Okay. There is no thing over here. Okay. Height filters. Okay, interesting. So PostgreSQL has limitless database, and then Babelfish. I think Babelfish is something. Okay, but I think if you say Postgres or MySQL compatible, you'll notice these. So you'll probably choose and expand filters for engine version. Ensure the version 3.02 is selected under available versions. Okay, let's just choose 3.02, I guess. So there is no 3.02. Wow, let's just go with this then. So templates, production, database 1, admin, and I want self-managed, master password, secure password, don't match. Now they match. Optimized, serverless v2. That's all. Right now, cool. Under the capacity range, choose minimum ACUs 1 GB RAM and 18 GB RAM. Maximum ACUs. Okay. So is 0.5, and then 18. No, 9. 18 GB RAM. Okay. Next, in the availability and durability section, select an Aurora replica or Vero node in the database. Okay. Create another. Okay. So don't connect to EC2 compute resource. Connect to. You'll specify where the database cluster will be deployed within your defined network. Your network has been deployed with a VPC that includes all resources needed for an Aurora serverless v2 database cluster. This includes the VPC itself, subnets, database, subnet groups, security groups, and several other networking constructs. All you need to do is select the appropriate existing connectivity controls in this section. Aurora VPC that allows you to connect to the database. To connect to the database, make sure the choose existing security group option is selected, and from the top, pick this area and any other. So default from the selection. And finally, database authentication may be used in some of the in the monitoring turn on performance insights and additional configuration. Type initial database name under failure priority tier 0 from the drop down. Choose one day backup retention and enable encryption. Also additional configuration and enable log exports. Check the error logging export. Slow query log boxes. Keep the selections in maintenance section. As is, deselect the checkbox and enable. In the production use case, you'll want to leave that option checked. But for testing purposes, unchecking this option will make it easier to clean up the sources once you complete the labs. The following characteristics require 3.02 or higher. Compatible with MySQL 8. Serverless DB cluster can scale between 0.5 and 9 capacity units. Deployed in a VPC and using the network configuration of the lab environment. Automatically getting backed up, continuously retaining backups for one day using data at rest encryption. So in my case, I think the database is already there, so I'm not going to create it. But basically, this is what I would do. So, for example, for monitoring, I think something I would say here. Monitoring, turn on performance insights now. Enhanced monitoring. So advanced, right? All of this, and I think this is fine. This one you can probably have this, and failure priority 0. Yeah, like all these. So this is default. Okay, they gave it as default itself, but yeah, initial database name, my lab, and all that. And also you can give IAM based authentication, and then that's it, I guess. Don't give these. VPC, choose existing default. The Aurora lab VPC. Then subnet, public access no, and Aurora lab this, and RDS proxy if you want. Yeah, that's all. Backup and all, I think we said one day. Retention period. One day. Backup retention period is one day. Yep. Cool. I think that's what is there. And now if I just click databases, okay, let me just say this is 60% over, by the way. Succeeded. Create DB instance for cluster. I think if I actually click databases, there should be a serverless thing over here. Serverless. Yeah. This cluster. And by the way, this one I can actually open it in a new tab, and there should be 2 of them. Awesome. Reader instance is getting created. Awesome. Okay, and this is probably already engine version is 8.0. Awesome. I just need to fail over and I should be good to go, I think. Switch over is not there yet. Okay. Cool. So serverless, we have serverless here, configuration 3.06 and whatnot. So forwarding is disabled and all that. Okay. Gather the cluster details, locate the cluster endpoint, and endpoints, writer instance. There should be a writer instance here. Reader instance, writer instance, which is so you'll note down this first, the connectivity, yeah, and then you'll need the instance name for this one for later for some reason apparently. So generate load on your cluster and observe scaling. So create CloudWatch dashboard, examine the scaling. So generate The DB cluster was pre-created for me. I created the cluster myself. Okay, what's the difference? I think not much. We'll use a Python script to generate load on the Aurora serverless V2 cluster if you've not already opened and once connected, run the load generation script from the terminal window, replacing the cluster endpoint placeholder. Just a moment. So if we've done with this, then we'll just have global database and machine learning. Okay. So replacing the cluster endpoint placeholder and the create section. In the following command, you created username and password during the cluster creation. After the command is executed with the correct cluster endpoint, it will report the number of concurrent connections, current connections, total threads initiated with the database, and it will also show the InnoDB buffer pool size, InnoDB history length, list length, and all that. So I think the same thing is true over here. So while the command is running, open the Amazon CloudWatch console and nothing. Okay. So let's run this. So bash, and let me close this up. So let me get this, and serverless demo 2, be my shop. Okay, cool. So that works. And in the navigation, choose dashboards, create dashboard in the Aurora serverless V2 file. Add widget, select line, add to the matrix. Okay, so let's look at this line, matrix, this, and you'll see this. Okay, say dashboard, put this in, instance name. Okay, what about this? Similar stuff. Yeah, cool. So let this run, and in the meanwhile, what is happening here? Anyways, I'm gonna actually just open up CloudWatch and create dashboards. I'll go to dashboards and then create a dashboard and call it Aurora my serverless V2, right? And then I'll say add widget line. Okay, so line, matrix, data type is matrix, I think. Line, choose matrix. So alarms, logs, so I want matrix, so yep. So now it's an untitled graph. So in the add metric graph dialog box, choose source and paste the below code after making the following changes: writer instance name and then region name. So copy this, and I think it's a JSON, so just put this in here, and okay, let's put this back over like this, and writer instance name is basically this, and then region name is US West 2. Cool. So now we can just get this. So it says RDS serverless database capacity, database instance identifier, this by access right, orders, offer type, fresh sale, flash sale, start sum, time series, and all that. Okay. So now I think so we are trying to add a graph. So we'll say source, and we'll say this. So cancel, do you want to leave that? Okay. So now I think should just save this and select some metrics to appear here. Okay. After making the changes to the region, paste the above code under the source tab, click on update and then choose create. Okay, so save the last 1 hour. Wow, nothing happens, huh? US West too, right? US East too? I thought you were on US West too. No, US West too. Oh wait, this one? Region US West too, yep. So this is right. I'm just wondering, image API, minimize source. So add first widget, line, and then multi-source query, graph, source. You say this is the source. Is it like, okay. I think I put an extra line over here, that's the problem. Yeah, now it should work. I should just say create widget now. And this should come in. So I'll say last 1 hour. And maybe custom, and let's say last 30 minutes. Or I'll say better last 15 minutes. Better last 5 minutes. Yeah, that's better. So we have that. And yep. To expand the widget, hover over and click on the maximize icon. So this, so you can see the last 1 hour, and if you want you can just expand on this. So this is showing in, this is the 1 hour thing, whole thing. This, so you can actually see this being scaled, by the way. So this is the flash sale, order 60. This is 9. This is able to take it, and you'll be able to see a similar graph as shown below, which is a plot of orders versus ACU, Aurora capacity unit. The number of orders, orange line, are graphed against the Aurora serverless V2 database capacity, blue line. As can be seen in the graph, at the start of the workload, the serverless V2 cluster is at the minimum ACUs, Aurora capacity unit. As the orders increase, the cluster scale to the maximum ACUs, and as the orders decrease, the capacity would continue to scale down. The metrics displayed on the dashboard are a moving time window. You can adjust size of the time window by clicking the buttons across the top right of the interface. You can also zoom in to a specific period by dragging across the graphs. All dashboard views are time synchronized. Zooming into the graph will adjust all views. So you can now toggle back to VS Code and Control C to pick the load generator. After a while, the Aurora serverless would scale to minimum ACUs automatically. While you're welcome to wait until that happens, you may also proceed to the next lab. Okay. Cool. So that's all. That's all there is to this. So we can actually stop this, and we can put it here, and we can actually notice this go down, I guess. So I think the custom is 5 minutes, right? So probably 15 minutes. So you can actually see the load going down. Now the load has gone down, so it has become almost like nothing. So last 10 minutes, I guess we can say. Apply. So this has to decrease in some time, and then we'll stop this. So Aurora serverless will be done. Maybe machine learning could be done next, and global database also, and then database activity streams and this. Anyway, so let me just wait for this to scale down, and then I will go ahead and do the other stuff later. So you can actually close this. Interestingly, my blue-green thing is now available, I think. It's done. Yeah, blue-green deployment is done. Successfully created blue-green deployment and a green database upgrade. Database green. View details. Cool. So you can actually see that this one says provisioning, but anyways, this one is the latest. And you can now switch over, I think. So once you switch over, I think. So green. This duration timeout 5 minutes. I think for the switchover they said something around switching over. I think switchover. You follow once you're ready to switch over, choose. Yeah. Cool. So we can actually just switch over. Pre-switchover considerations appropriately apply IAM policies. IAM roles aren't copied over from the blue environment to the green environment. Make sure that your IAM policies are appropriately applied to the green environment before you switch over the blue-green deployment. Reduce costs by deleting old blue databases after switchover. We recommend that you delete the old production environment Aurora Lab UPG Node 1, Aurora Lab UPG Node 2 after the switchover completes if you no longer need it. You are billed for old instances according to the standard pricing model for DB instances. Switch over, and it's switching over. So, yep. So that's happening. While that happens, I'll just reload this. And machine learning, we can do this. Let me see this scaling down in the meantime. So this is scaling down from 9 to 6. Next it should scale down to 0.5, I think. So in the meanwhile, can we do some machine learning stuff? So machine learning integration with Amazon Aurora currently supports Amazon Comprehend and Amazon SageMaker. Okay, natural language processing, and this is the center for all your data analytics and AI, Amazon SageMaker. So Aurora makes direct and secure calls to SageMaker and Comprehend that don't go through the application layer. Aurora machine learning is based on the familiar SQL programming language, so you don't need to build custom integrations, move data around, learn separate tools, or have pure machine learning experience. The lab contains the following tasks: set up a sample schema and data for ML labs. This lab requires enable choose yes. Get started, choose yes for enable ML labs. So if you've not already opened unsubmitted, so if you've completed the previous lab and created the array manually, you would find the value of the cluster endpoint here. Cool. So not sure if they had enable Aurora Labs feature option, but anyways, let me actually just put this in. Okay, let's give this here. Okay, so let's go and put this in here. Oops, terminal code reference log. I don't know what this is, but anyways, okay, delete new terminal. Oh wow, what happened here? Oh, there is no internet. Okay, let me check what happened to my internet. Okay, looks like my internet died on me. In the meanwhile, I'll just check out these and then probably continue later. So it says execute the following SQL queries to create the ML test database and tables and populate them with data. Okay, so drop schema, create schema, use ML test, and then drop table if it exists. Comments, comment text. This is very useful. Thank you for writing it. Awesome. I was waiting for this feature. Okay, so these are like comments. and churn. So you have churn.txt that you are loading in, verify that the schema was created correctly, and show the tables, disconnect. I think that's all I can do. Just a moment, let me see if I can actually get my internet is working again. So let me just do this. Okay, it's still not connected to the, okay, I disconnected the internet. Yeah. Cool. So now I think I can actually do this. Yeah. Cool. So I'm just gonna go ahead and run this SQL. This. Okay. By the way, this has gone down to how much? Oh, it basically died, I think. Okay, it has gone down to 0.5. Yes. This has gone down to 0.5. In between there was something higher, I think. Let me check this out. So this was 1, and then this is 0.5. Every 10 seconds is too much, maybe every 1 minute. So this is 0.5. This is 1 apparently. Anyways, I don't know why it went up to 1 at times, but it is 0.5 now, so all is good. So let's close this up. I can save this and then close this up. Cool, so I'll copy this. And switching over production traffic has happened, and so we can actually just reload, and we should see no blue-green stuff. This is old stuff, and this is what is the new stuff. And here you can just upgrade. You can just delete this whole thing, I think. Stop temporarily. Setup, stop temporarily, blah blah blah. Delete me. We can delete this one also. Delete me. Cool. So you can actually see that these were having old stuff, MySQL, you see. So auto enrolled and all that. So old stuff. Right. This one has new stuff, but you can actually upgrade this. So before that, let me see if I can actually just stop temporarily or delete. Yeah, this also delete. Create final snapshot, no. Retain automated backups, no. Acknowledge that, provide additional written consent, delete me. I strongly recommend taking a final snapshot now. I don't need it. Cool, so we are doing 3 deletions over here. Yeah, so you can stop the cluster temporarily, as it seems. Anyways, so now here I'm actually gonna take this up. This is just a blue-green configuration. Here I want to upgrade this. So I'll say modify over here, and for engine version I'll say 0.40 and say continue. So 0.82, so apply immediately. Blue database associated with this green database. To change, modify it directly. Yeah. So here after the blue database will not get modified. Only the green database will get modified. So successfully modified, and you have these is being deleted. Deleting this. Okay. Cool. So I can actually open this up once. So it says upgrading. So you can actually see the configuration to be 082 now here. Switchover is complete. Wow, okay, because blue instance engine version is this and the green instance is this. Switchover was completely completed successfully, was successfully completed. And do we have some recommendations even now? Let's look at the recommendations latest. Increase in charges. I think this is regarding the UPG thing one day ago. Okay. You can't apply anymore because I think it's an old thing. Have only one DB instance, UPG cluster, and then standalone, standard storage, and whatnot. I have my storage, okay. But I'm not running on the latest minor version. Okay. Database performance and database security at risk. Data security at risk, data availability at risk. Cool. So yeah. So you can't apply any of these, I think. Oh, you can apply this and you can apply this. Anyways, we have 3, 5, and 1. This thing. Okay. 2, 5. Okay, so this, if I reload, this will become 2, 5 becomes 3 have only 1 and 5. Okay. Cool. So this is deleting, so it's fine. And okay, I think it's already deleted. Let me see. Let me reload this. So it still says deleting anyways. So once this is deleted, I think this will go. We don't have any other 5.7 MySQL thing available, I guess. Anyways, now we'll look at this. We'll come back to this. So we have run this load data and all, right? And show tables. So let's look at show tables. So this is load data, everything is done. Customer service calls, churn and all. So should be able to see 2 tables, churn and comments as shown below. If you don't see the tables, read on the commands, quit. Okay. Use comprehend with Aurora is a natural language processing service that uses machine learning to find insights and relationships in text. No machine learning experience required. This lab will walk you through the process of integrating Aurora with the comprehend sentiment analysis API and making sentiment analysis inferences via SQL commands. Create an IAM role, okay, to interface with comprehend. Associate the IAM role with the Aurora DB cluster and add the IAM role to the DB cluster parameter group and apply it. Run comprehend inferences from Aurora. Okay. So you copy these. If you're not already open, so create role, dash, create role, comprehend access, version this, statement effect, allow, principal, RDS action, assume role, put role, policy. So this is the create role. Put policy, role policy. Role name is this. Policy name is inline policy. Action, comprehend, detect sentiment, detect bash, detect sentiment on all these. Okay. So we can run this here. Okay. I can do shift G, I think. It goes to the end. Oh, I shouldn't have done that. I should have gone down properly. Anyways, so it skipped some things, but anyways, what to do? So I'm guessing this has done the both path, role name, comprehend access. So put role, I'm guessing I'm going to go and check out the roles maybe. By the way, let's see if this is being deleted. No. Oh, one is deleted by the way. So you can actually see successfully deleted DB instance, old one, node 1, old one, node 2, old one is going to be going, and this was modified. Okay, so you can just reload this and you'll see that. And let's look at roles in IAM, and you should be able to see this role we just created, which is Aurora Lab Comprehend Access. Comprehend access. Okay, so permissions, inline policy, detects sentiment, batch detects sentiment. Okay, so this is present. Edit policy, this is an inline policy. Okay, so I think create role and then assume policy document, put role name, and then policy name. Okay, cool. So this permission boundary, where is the assume, by the way? Assume role, I can't see it. Is it trust relationships? Oh yeah, here. This is basically this part. Assume role policy document. So RDS can assume the role. Principal action, principal service, and then action is assume role. Okay. So now after this, associate IAM role with the Aurora DB cluster. Okay. So run that now. Okay, so next run the following command and repeat until the output shows available. Okay, describe DB clusters until the output shows available. Okay, it's already available. Okay, before moving on to the add the IAM role to the DB cluster parameter group and apply it. Okay, so this one is about add the role to DB cluster. Okay, so role ARN and get the role, right? And then here we are saying add the role to the DB cluster parameter group, modify cluster parameter group name, parameters, parameter name, comprehend role, parameter value, and list roles, this ARN, and apply method pending reboot. Okay, so basically we have to say this parameter name AWS default comprehend role. So this is done, and reboot the cluster DB cluster for the change to take effect. To minimize downtime, use the manual failover process to trigger the reboot. Okay, cool. So now run the following command and wait until the output shows is available before moving on to the next step. Okay, it's failing over. Let's actually wash this. Failing over. So run comprehend inferences from Aurora. Okay, so you can just go ahead and do this MySQL thing. MySQL Edge. Aurora has built-in comprehend function which will make a call to the comprehend service. So it will pass the inputs of the AWS comprehend detect sentiment function. In this case, the values of the comment text columns in the comments table to the comprehend service and retrieve sentiment analysis results. Comment text English confidence as confidence from comments, and you will see this. So edit policy and all I don't need to see. Okay, deleted instance, no 2 also. Awesome, this is being deleted. Okay, awesome. So I'm just gonna go ahead and check this out. Okay, so this is available. Awesome. So let me say this, and then select comment text, and then no database selected. Okay, sorry. So my lab. Okay. Comments doesn't exist. Wow. Okay. I think we have to connect to ML test. Sorry. Okay. ML test, and then this. I'm role AWS default comprehend role. Okay. Looks like it's missing the role. Default comprehend role. I did update it. Describe query status. So failover. So we need to look for this parameter name to see if this is there. DB cluster PG. What is PG? Parameter group. Okay. I need to look for DB cluster PG. So this one. Let's look for it. So this was deleted. Awesome. And this is also available now. And this is the latest version. There's nothing else to modify over here. I think you can't go higher than this. And you can't downgrade this. You can only upgrade. Cool. So this is clear. And I want parameter groups. Let's close this. I want this parameter group. So this one. Yeah. So open this up. Parameters, these many. Comprehend. Default comprehend role. Okay. Value is this. Parameter value is get the ARN. Okay. I got the ARN, yes. And pending reboot. Modified. And we did reboot, but let me actually check it out. I think designated IAM role this. We did rebooted. Maybe I'll just do say reboot, stop temporarily, delete. To release this, you need first delete or remove the database instance within the daily cluster. Okay. So I think a reboot will help. Yeah. Let's see if this works out. Let's see if this is available. So it is available as of now, but it's still rebooting. I think I'll reboot this also, but this is just the. Will the writer become reader? I don't know. We did do a failover, I think. I don't know. Events. So a few minutes back, we actually shut it down and restarted. So, anyways, this one was for this one. Logs and events. Okay, recent events. So you can actually see that we just ran it just a few minutes ago, node 1, and completed, and this big node 1 became the writer instance. Now this is back again, and run this. Missing designated IAM role. Anyways, okay. So finally, you just run this and you get it. There's nothing else to do here. For some reason, it doesn't show up. I'm not sure why. It looks like there's some issue. Missing designated IAM role. This. I think this is missing it. An IAM role. Is it? Configuration. IAM. Maintenance and backups, recommendations. Anyways. Okay, so I think it thinks IAM role has to be this. Oh, I think this shouldn't have been default component role probably. This should probably have been this maybe. Interesting. Does parameter groups have these things? Parameter groups. This parameter group. Comprehend. Can it have hyphens? Yes, it can. Let me just say oh, mm, 6, 8, 10, 12, 14, 16, 17, 20. Cancel again and interesting. So I don't know. Missing designated IAM role comprehend. I don't know. This says weird stuff, but anyways, use SageMaker. I'll probably do this later, and then yep, at the end you can just delete all these things. I'll probably do the global database stuff and SageMaker and database activity streams and IAM authentication later. That's all I had for this video. I'll see you next one. Bye bye.